All right, let's take a look at section 4.6. Okay, special products. When we multiply binomials together, there are circumstances where the setup of the binomial is the same sort of setup, and we do this a lot of different times, and that's not making any sense whatsoever. So let me just get into um, what I'm talking about. So let's suppose I have x plus 4 and I want to square it. Okay, so what this means is x plus 4 times x plus 4. Okay, when we multiply x plus 4 times x plus 4, we multiply the x times the x, and we multiply the x times the 4. And this time we multiply 4 times x, but because these binomials are the same, notice I have the x times the 4 here, but I also have x times 4 here. So I end up with 2 of these 4x's. And then we have 4 times 4, which is 16. So in this upper left-hand corner, we have the variable squared. In the lower right-hand corner, we have the constant squared, and then we've got 2 of these. Okay, so x squared plus 2 of these plus my 4 squared is what ends up happening. Final answer would be plus 8x plus 16. So I ended up squaring my variable, squaring my 4, and then I took 2 of these multiplied together. Okay, so my preference is when you square a binomial, you draw a box and you do it that way, because students generally get it wrong when they do it any other method. But that being said, there is actually a formula. So if we have to square x plus y, our final answer is going to be our first one squared. Our last one squared is going to go in the last place. But then I have these two multiplied together, and I've got 2 of those. Okay. The square of the first term, twice the product of the 2 terms, and the square of the last term. Doesn't matter if it's x plus y or x minus y, it works the same way. Be careful when you square the y because it's actually negative y. Negative y times negative y is positive. So technically, you can use these 2 formulas to square a binomial. The problem is that I've run into a whole bunch of students. I've taught literally thousands of students, and very few of them actually remember the formula. So I don't recommend trying to memorize the formula because you're probably not going to remember it. I mean, you can absolutely go for it, but you're better off doing the box. 2x plus 1. So we've got 4x squared, 2x, another 2x, and a 1, which will give me 4x squared, 4x plus 1. If we were to do it using the formula, we would have 2x, got 2 of my 2x times my 1, and I've got 1 squared. Be careful. This is one of the reasons why students get it wrong, because when they square this 2x, they tell me it's 2x squared, and in fact it's 4x squared. When we multiply these out, we've got 4x plus 1. Notice we get the same answer. We can do the same thing with this. Again, my preference is to have you do it using the box. Guys, this is an S. I know my S's look like my 5s and vice versa. So 25r squared minus 30rs, another 30rs, and a positive 36s squared for a total of 25r squared, 60rs, 36s squared. All right. Use a box. 3k minus 1/2. So 9k squared. Remember, when we multiply a whole number times a fraction, we multiply, or divide by the bottom, multiply the top. So we end up with 3 halves k, another 3 halves k. Fraction times a fraction. We multiply the tops, we multiply the bottoms. All right, now we have to add these together. So 9k squared minus, if I have negative 3 halves minus 3 halves, I have a common denominator already. So this would give me negative 6 halves, which will give me negative 3. Plus 1/4. We did something similar to this already. Remember, I want you to multiply the binomials first. Multiply the binomials first, then distribute the x. Do not distribute the x here. It won't work. I'm telling you, it doesn't work. You got to multiply this. Again, my preference is for you to use the box. So when I combine like terms, 4x squared, 28x plus 49, and now distribute the x. So 4x cubed, we're going to multiply and multiply. We have 28x squared and multiply. 49x will be the final answer. Same thing here, only you are going to distribute using a negative 1 after you square this. So negative 1, and let's use the formula just for practice. Plus, okay, so 4t times 4t is 16t squared. If I multiply the 4t times the 2, I have 8t, and then I have 2 of those. 16t, and then we're going to distribute. Okay, this one right here, super, 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 super important. We use this a lot. We use it so much, so much, so much, so much. If we have 2 binomials where this number is the same as this one, and this one is the same as that one, and one is a plus and one is a minus, then we're going to end up with x squared minus y squared, because let's show why x plus y, x minus y. So it doesn't matter what the x and the y are. It happens every time it's this situation. Notice I have a positive xy and a negative xy. They will cancel out every single time when one is positive and one is negative. All right, so this one I do want you to use the formula. So our final answer, we're going to take this squared minus this squared. 9 minus y squared. We're going to take the first term and square it, and the second term and square it. Be careful, you got to square the 10 as well. M squared minus 49. Square the first term. square the second term. Multiply these first and then distribute the x. So square the first term minus the square of the second term. Now distribute. Same thing here. We're going to multiply these first and then distribute. So we're going to square the t squared. You guys know that t squared times t squared is equal to t to the fourth, correct? Minus q squared. Now distribute. Negative 7 t to the fourth plus 7 q squared. Okay, so on the last, sorry, I think it was the last section, we did this, and I showed you how to do it. What you're going to do is you're going to 4x plus 1, 4x plus 1. Okay, so you're going to multiply two of them, and then you're going to multiply by this binomial. Okay, so if you want to use the formula on this at this point for squaring this, that's fine. If not, times 4x times 1 plus 1 squared. Two times 4x times 1. This last one you have to use a box for, or multiply vertically. (16x squared, 8x, 1, 4x, and 1. These are positive. 64x cubed. Remember, you add the exponents when you multiply. When you multiply, you add the exponents. 32x squared, 4x. 16x squared, 8x, and 1. But when we are combining like terms, that x squared is going to stay x squared. I think I ran out of room. 64x cubed. And then we're going to combine these. So we've got 32 plus 16 is 48 x squared. We've got 12 x's that we can combine and a 1. Oh, golly. 3k minus 2. 3k minus 2. 3k minus 2. 3k minus 2. Now this one, we're going to multiply them kind of two at a time. So we're going to square this, but we kind of already got it because it's going to be the same thing. So 3k, by the way, you can use the box. Plus, and this is going to be the same. So 3k plus 2 squared. All right, so where are we at? We have 9k squared. Let's see, 6 times 2 gives me 12k plus 4. Not done yet because we have to multiply these together. So let's draw a giant box here. (9k squared minus, when we square a binomial, it doesn't work for trinomials. We can't, there's no formula for squaring this. 9k squared minus 12k plus 4. There's no formula for that. All right, so we have 81k to the fourth. I don't remember 9 times 12. I'm terrible at my 12s. 9 times 12 is 108. 36k squared. So another one of those. And 144. And minus 48k. And then a 36k squared. Minus 48k and a 16. All right, so 81k to the fourth minus 216k cubed. I'm going to have to use a calculator for this one. 36, 144, 216. K squared. And 96k and 16. Woo! Hopefully that's the last one. No! All right. Okay, so we're going to cube this, and then we're going to distribute. So x minus 4, x minus 4. Oh, yowza. All right, so x squared minus 2 times 4 times x plus 4 squared x minus 4. And our box. So x minus 4, x squared minus 8x plus 16. Okay. Minus 4x squared, 32x, and 48. So I've got my negative 3x, and I've got my x cubed. Negative 12x squared. 48x minus 48. And now distribute. Oh, thank goodness this is the last one. 36x cubed. I don't know what 48 times 3 is. 144. And 48 times 3 again. X, and that should do it. All right.